Hello, everybody. Welcome to the talk about BMW's augmented reality ride concept. It's great to see so many people here today. It looks like there are many BMW fans among game developers. Maybe it's because many of you like racing games. Maybe you're not interested in BMW at all. Maybe you're just interested in what is a car manufacturer doing on a conference for game developers. So this is me. I'm Tobias. I'm an augmented reality software engineer at BMW Research. I'm part of a larger user interaction, user experience team. We focus heavily on XR technologies, ranging from future head-up display development all the way to augmented reality glasses. And our job really is to kind of anticipate the future. So as you might know, building cars takes a lot of time. So from the start of development all the way to the start of production can take up to 5, 6, or even 7 years. And our job is to make sure that we put the technology into our cars today so that they are ready for being in 5, 6, or even 7 years. And there is a question we asked ourselves many years ago. So what if augmented reality glasses, like this one, lightweight, kind of small form factor, what if augmented reality glasses become an everyday device, kind of like the smartphone? How do we integrate these into our cars? If the customer is used to be using AR glasses at home, how would it change the way how we interact with the car? And can we create truly immersive experiences? So these are some of the questions we asked ourselves many years ago, and I'd like to address today. So this is the agenda. I just wanted to emphasize one thing in advance. So this talk is going to be a little different from the presentations you have seen so far. The reason is, so this is a research project we started at BMW Research more than 15 years ago. It has been confidential most of the time. We went public with it beginning of this year, and we have never given a talk like this before, so this is a first. And I would like to explain why BMW is using augmented reality. I want to give you some background on where we are heading to in the future. And I would also like to explain, and I'd like you to understand why using AR glasses in moving cars is incredibly challenging. So I'll be talking a little bit about Unit here, but please don't expect that you can go home after this talk and just develop apps for any AR device at home. This is going to be very difficult. So I'll be starting with a little bit of history. Then I'm going to explain why we are doing this. I'm going to explain what the main challenges of in-car augmented reality are. And wait for the results. The results are truly amazing. They are amazing. So pay attention, please, all the way to the end. So I'd like to start with a little bit of history. This is the BMW 1500. And I really like this car because everything in this car is driver-centric. So you have your steering wheel, you have your clock, you have your tank level indication. And there is nothing which distracts you as a driver from your driving task. Now, I'd like to fast forward 40 years to the future, and please pay attention on how much the car interior has changed over the years. Now, this is the BMW M5. It's an amazing car, but you can tell a lot has changed. We put so much technology into our cars over the year to make driving safer, to make it more fun, and also to make it more comfortable. And you can see that more and more displays are taking over the car interior, and we are continuously challenged with providing the best possible UI to the user because we would like to give the user all the information he needs. But at the same time, of course, we don't want to overwhelm the user. We don't want to distract him. And the head-up display, which you can see above the steering wheel, is a great example. So originally coming from aviation industry, BMW introduced the head-up display more than 20 years ago. And it's great because you can now put driving relevant content right into the driver's line of sight. So you can keep your eyes on the road and we can reduce distraction. Okay, so let's jump another 20 years to the present. This is the BMW 5 Series from this car. Again, a lot has changed. More and more displays are taking over. The car interior displays became larger, and also the head-up display became larger. It's now in full color. We can show navigation instructions, speed limit information. Maybe you can just show who likes head-up displays of you guys. Okay, that's quite many. So if you ever driven a BMW with a head-up display, I think most likely the next car will also be a BMW with head-up display. And we at BMW Research, we ask ourselves a question: how can we bring this to a whole new level? Let me give you an example. I'm convinced that placing information there where you need it is probably the best way to do it. So having this navigation instruction here sitting on the road, telling you to turn right at the intersection, is probably the best way to do it. But with today's technology, we are not quite able to capture the whole windshield. So even though head-up displays are great because they put driving relevant content into your view, and head-up displays become larger and larger over the years, the field of view is still very limited, and there is no technology, at least I'm aware of, which can span over the whole width and height of the windshield. And this is the great benefit of augmented reality glasses. So if you put on the glasses, you have this massive field of view you can use to augment the environment around you, not just in front of you, but also to your left and also to your right. And the same is true, of course, for the passenger. So why use augmented reality glasses inside the car? As I said, having this large movable field of view is probably the largest advantage. And the question we get quite frequently is whether AR glasses will replace head-up displays in the future. Our answer is that we believe that AR glasses are a great extension to already existing head-up displays. So we believe that head-up displays can coexist with AR glasses and just extend the limited field of view we have in the head-up display. And since we also know the position of the device, of the augmented reality glasses, we can make sure that we don't show the same information at the same time, and we can do a seamless extension from the head-up display to a spatial augmented reality. And this is also a great benefit of augmented reality glasses. You can bring entertainment to a whole new level. We can do immersive experiences, we can do enhanced gaming, we can do 3D videos. And for the driver, we can improve safety by placing everything into the driver's line of sight, so we can reduce the cognitive load of the driver, and you can keep your eyes on the road. Now, let me talk a little bit about more advantages of AR glasses over other in-car displays. So as I said, so this is a picture, and I'm going to show you a video afterwards. This is a picture I shot through the AR glasses, and just gives you an impression on what is possible with AR glasses. So you can place content where you need it, not just on a fixed car display, but also on the road in front of you. And another great benefit is that you have personalized content for everybody. So let me give you an example. Let's say we are on a family trip. So mom is doing the driving, so she has the glasses on with all the navigation and guiding in the glasses. And dad is sitting on the passenger seat. He has some work stuff to do, so he's working on an Excel sheet in a virtual window, of course. Then he's writing emails in another window, and he's looking at a presentation in another window. And the two kids in the back, they can just use the glasses to do some immersive gaming, and maybe the other kid, he wants to watch a video or so. Now you're like, okay, what is this type of family? Everybody in this own world in glasses. And of course, you can use glasses to bring everybody together. So let's say after 15 minutes, dad is finished with work, and then dad and the kids are watching a movie together, or they are playing a multiplayer game in the glasses. Has not been possible before. So you can have personalized content for everyone. And only with AR glasses, we are able to create truly immersive experiences. So this is another picture I shot through the glasses. It's a little game. I'm going to show you a video. And it just shows the potential of augmented reality glasses. All right. I hope you're convinced that AR glasses kind of make sense. So at least we thought, let's bring AR glasses into our vehicles. So was about 2012, 2013. We reached out to glasses manufacturers, and we told them, yeah, there is this set of use cases we would like to do for the driver and the passenger. We would like to do navigation. We would like to show a point of interest. We would like to do immersive gaming for the passenger and watching a video. Can we do it with your pair of glasses? And they were like, no, it's not possible with today's technology. And this was very disappointing for us, because we kind of expected that you can just use AR glasses in a moving car. So this was very disappointing, and I'm going to explain you why. And so I also teach augmented reality at university, and this is a slide actually I show to my students all the time. Don't worry, it's the only slide from my university lecture. But it's very important to understand how augmented reality glasses work in order to understand why they don't work in a moving car, at least out of the box. So this is what we call the tracking rendering pipeline. And this is true mostly for any type of augmented reality glasses. Also kind of true for those mixed reality glasses we see out there. So you put on your glasses, then of course, let's start from the left side, then you have head motion. And ultimately what you would like to do is to display something on the display. And so you have to run through this whole pipeline. I'm gonna go through each of it. So you have sensors on the glasses to capture your head motion. Then tracking is concerned with taking the sensor input data and calculating the position and orientation of your device in the world. Then rendering, of course, you guys know about it because Unity is concerned with rendering. And then you can bring it to the display and you can see that. Now, with AR glasses, you have to do this really, really fast. So this runs with display frequency, at least 60 FPS. And so it runs with display frequency, and then you have to do this really, really fast. We call this, it's called the motion to photon latency. So this should stay below 20 milliseconds. We know that from literature and also from experiments. So this whole pipeline, sensing, tracking, rendering, has to be very, very fast. So let's go through how the devices usually do that. So there's two types of sensors involved. So you have cameras usually on your glasses which look outside and try to capture the environment and track on the environment. Now cameras are great. So usually there is at least 2 cameras involved. Now I know the Meta Quest Pro and the Apple Vision Pro have many more cameras. It just makes accuracy a little higher. But cameras have the problem that it's very expensive on the CPU and GPU to run computer vision, and it's kind of slow. So it takes usually on mobile GPUs at least 10 milliseconds. And this is why another type of sensor is also on the device. It's called IMU. I think this is a pretty standard abbreviation these days. It stands for Inertial Measurement Unit. It's basically a sensor array which gives you acceleration and angular velocity. And I would say it's the most important sensor on any headset because it's really, really fast. So if you combine camera-based tracking with IMU-based tracking, then you can calculate the 6 degrees of freedom pose of the glasses with respect to your environment. Now, then rendering, and rendering is slow. It's terribly slow, and it's not Unity's fault. It's not even Qualcomm's fault. Mobile GPUs are quite fast these days. It's just rendering is concerned with so many computations that it takes couple of milliseconds, so roughly, usually between 30 and 60 milliseconds. So this can be, of course, faster, but it also can be slower. And then the display roughly takes 3 to 5 milliseconds. And you just need to add those numbers, and you already know that we go beyond those 20 milliseconds. And this will destroy the whole immersion of the AR glasses, especially if you're on see-through AR glasses, because everything you will be looking at, and if you shake your head, it will shift with your head movement. So it's not locked to your environment anymore. But luckily, there is people out there, smart people, and they came up with a solution, which is a post-rendering latency compensation. So after the image is rendered, so if you put the 3D scene on your 2D images, and of course there's 2 different images, slightly different images for each eye to have stereoscopic rendering. So if the scene is rendered from 3D to 2D, let's say it takes 50 milliseconds, then you look on how much the head has moved during that time, and then let's say it has moved to the left, and then you try to shift the image on a 2D plane to the right. And with that, you can bring rendering latency below 5 milliseconds. So we are fine with the motion to photon latency. And I just wanted to emphasize this, so I'm now finished with my lecture, because it's very important to keep in mind the tracking rendering pipeline to understand the difficulties we have in moving cars. Now, let's go back to our talks with the glasses manufacturers. And so they said XR devices work fine in stationary environments. So we already knew that, so it just works fine here on the stage. Because they use sensor fusion of tracking cameras and IMU. We also know that already. And the problem now is if you jump into a moving car, we have two sorts of problems. First, the IMU measures, as we know, acceleration and angular velocity, but it cannot distinguish between head motion and car motion anymore. So this is an issue. And then we also have an issue that cameras see the kind of static car interior, but also the fast-moving world out there. So without additional information, data cannot be fused. So you can't estimate the device's location in your environment. And then we have another issue. So a lot of times we drive in the dark, and without additional illumination, there is just not enough information for the tracking cameras to track on inside the car. And I took a video, my team took a video here in a moving BMW at night, and you can see there's not enough information to do the tracking. Now, I had some conversations yesterday, and they were like, yeah, this kind of makes sense, but the Apple Vision Pro works in a car. And I was like, no. So this person was multiple person were telling me that they used the Apple Vision Pro on a plane. They have used the HoloLens in a train. And so we also try to do the same thing. And just to give you an impression, we also took a video. So there is, if you just take the Apple Vision Pro or the Microsoft HoloLens or Meta Quest Pro in a moving car, it would not work. And the engineers at Apple and Meta, they know that already. So they came up with specific modes. It's the travel mode for the Apple Vision Pro, which you turn on if you go on an airplane. And Microsoft has this moving platform mode. And I would like to emphasize, so those modes are intended for kind of slow moving platforms, but they are not intended for fast moving cars. So if you go dynamically in a car, in a BMW, then it doesn't really work. So we tested with the HoloLens, and you can see it kind of works, but if you compare the edges of the virtual augmentation here, you see that it's kind of shaking. I can play it one more time. So I would say Microsoft does an okay job of tracking in a moving car. It slightly works better in the back if you're on the second seat row, because then there is less information from the outside. And it doesn't work in the dark, so it fails. Now, when Apple Vision Pro was released beginning of this year, we also wanted to give it a try. And this is the result. It is actually slightly worse than the Microsoft HoloLens. And so I'm not blaming Apple for that. Apple has one of the finest engineers out there. It just tells you how hard it is to get the tracking right in a moving car. And I hope you're grasping to understand what the issue is at BMW Research. So we wanted to use AR devices in a moving car, but there is no solution out there. Even with those like headsets with those chips and so many cameras, they are not capable of doing tracking right in a moving car. And I'm not encouraging you to try this out, because we are not aiming for devices like the Apple Vision Pro, because it's just too large for the driver and the passenger, of course. We are aiming for small devices like the one which is sitting here over there. But so the thing is, if you try it out in a moving car, And if you have an accident, we did some crash simulation, then the headset will come off, airbag opens, and it will throw the headset into your face. So please don't try this out. Maybe you can try it out on the second seat row, but be very careful about it. Now, one more thing. So we usually distinguish between vehicle-locked assets, and again, Microsoft HoloLens, Meta Quest Pro, Apple Vision Pro, they can only do a vehicle-locked tracking, because if you would like to do, okay, let's talk about vehicle-locked tracking first. So you know the assets you would like to display within the car space. So there's the transformation from your virtual asset to your car coordinate system, and then you know the position of your device within the car, and then you can do the tracking, the rendering, because you know the relationship of your virtual thing to your device. Now, if you want to do that for world-locked assets like navigation instruction we have here on the road, you would need to know the position of the car in the world with high precision. And out of the box, the devices out there cannot do that. So because of all these limitations we have here, so we came back from our talks with multiple glasses manufacturers. Everybody told us it's not possible, at least not the way we wanted it to have. So we paused use case development for a time. We actually wanted just to do a use case development. We asked ourselves, how can we bring use cases to the driver and the passenger? So we paused that and started working on getting the basic system up and running, getting the tracking running. And our idea was to take the camera we already have in our BMWs. So there is regulations which require you to monitor the driver. And the cool thing about this is we have infrared illumination because we need to monitor the driver anyways, also at night. And our idea was to use the camera to track the glasses inside the car. And of course, there was no solution for that. So that was many years ago we started that. So we started building a whole motion capture system into our cars. So maybe you know those motion capture studios for the film industry, where you have your cameras around you and then you put markers on your body or on a device, and then you can track the device. We did the same. So we put many, many cameras into our car. We put markers on the glasses, and then we started working on the tracking part. And after some years, we got it running. And then we were like, okay, we would like to get rid of the markers we have on the device. So we started training our own neural network. So we collected training data sets, millions of images. We defined the network of the architecture of our neural network, did the training, did the deployment, put it into our cars. And here you can see the result. So, and you can see two types of outputs, what our neural network does. So it gives you the bounding box of the classes and also the pose. And this is what our solution looks like. So we have the car, we have the smartphone, and we have the X-ray glasses. Now, the glasses today are still tethered. X-Ray had this idea to bringing up a headset, a pair of augmented reality glasses, which is really lightweight, so they take advantage of the battery and the CPU in the smartphone. And we hope, of course, that we will get rid of this cable in the future, and this will likely change in the future. So we have the glasses which are connected to the smartphone, and we build our app with Unity. Now, as I said, we use Unity a lot at BMW Research. We use it for augmented reality glasses, but also for head-up display development, which is why Unity is just great for us, because it helps us to do quick prototypes. And all the things I told you previously about tracking is done here in our Sensor Fusion library. So we have a library which is programmed in C++, which is platform independent. We take sensor data, IMU data from the glasses, and tracking data like the vision data we have seen on the slide previously. We take car motion data, we take high accuracy GPS data to get all the tracking right. And then we just use this library as a shared library within Unity to update the position of the virtual augmented reality camera within Unity. And then we also transmit use case data like navigation instruction And with this, we can go to the renderer, we can do the latency compensation, and we can put the display, we can put the image on the display. Now, this of course requires the SDK of the X-ray classes we're using here to open. And this is also why we announced our collaboration with X-Reel beginning of this year. And now it's getting exciting. So what does the in-car experience actually look like? And as I said, BMW has been working many years on that topic. In fact, we started with this specific project in 2008. So after we introduced the head-up display into our cars, we thought, what's next? And we started building our own kind of headset because there were no headsets out there. Google Glass, I think, was released in 2012. And we first went public in 2015 with Mini. Mini is part of the BMW Group family. And we showed a first look at how AR glasses can enhance the driving experience and came up with some use cases. We presented everything at Auto Shanghai, and this whole demo, you can watch the whole video online, it's on YouTube, is called Mini Augmented Vision. But note, this was only a stationary demo. It did not work in a car. So after that, we, as I told you, we came back, started working on the tracking part, and in 2019, we reached our first milestone, is that we kind of got the tracking part working. So this is actually filmed through a pair of glasses. And I decided to take this video on purpose because can show you it again, because it shows you the difficulties we have. And this is all related to tracking and the rendering. So we got the tracking solved here, but we didn't have access to the latency compensation feature. And this was the slide I showed you before, the university slide. And so it kind of worked. We used OpenGL for that, but we still had many troubles. So after that, since we kind of solved the vehicle lock tracking part, we started working on the world locked tracking part. So we took GPS data from the car and did all the sensor fusion and algorithms there. And we also transitioned at that time to different pair of glasses. We used the X-Reel glasses. X-Reel was called N-Reel back then. So we were able to use Unity for that. And this is another video we took back in 2021. And I'm showing you these videos with all these issues by purpose, just to show you how difficult it is to bring augmented reality glasses into our cars. Let's play it one more time. So you can see that accurate placement is a big difficulty. And this is not mainly because of the tracking, it's because we had too much latency in our system. And yeah, after 2021, we started working on the reducing the latency. And this year, we went public with the augmented reality ride concept from BMW. So we presented it at the CES in Las Vegas this year. It was the world's first fully immersive AR glasses experience in a moving car. So visitors were actually able to jump into a car and just experience the use cases themselves. We use the X-Reel glasses because they're very lightweight and can project high-resolution content into your environment. So unlike a VR headset or the Apple Vision Pro, which sort of keeps you enclosed, with see-through AR glasses, you can see everything normally, like with sunglasses. But you can also see projections. We developed use cases for the driver with like driver assistance. And we also came up with immersive entertainment use cases. And Unity asked me to bring the car to Barcelona. I couldn't, unfortunately, so I brought this video instead. Hope this makes it up for that. So you can see, so this was recorded in Las Vegas. You can see the person here sitting on the passenger seat wearing the X-Reel glasses. And this kind of gives you an impression of what our experience looked like. So we went on a ride around the convention center. And we at BMW Research are always dedicated to build prototypes which work. So we are dedicated to build fully functional prototypes because anybody can do fancy videos and fancy presentations and slides. But building prototypes which work makes it so much easier to make the right decisions for the future, because this will affect millions of our cars. All right, so I'm going to show you the results in a minute. Just wanted to emphasize one thing. So this is my office, at least sometimes. It's one of our prototypes cars. We have multiple cars in our department which can use augmented reality. And I wanted to show what it actually looks like if you put on the glasses. And because there are so many fake videos on the internet with CGI, where there's beautiful augmentations in a video, post-rendering and post-processing, I didn't want to do that. I wanted to show you what it actually looks like if you wear the glasses. So this is our setup. You can see the tripod. There is the glasses sitting on top of it. And we put a action camera behind that. It's this one here. And it films through the glasses. And it's actually very difficult to get good quality videos because there is so many different lighting conditions. Then you have to synchronize display frequency with sensor frequency. You need to get the exposure time right to avoid tearing lines. So anyways, I'm just emphasizing this to let you know, okay, all what I'm going to show you now, it's not fake, it's real. And yeah, here's the results. So this is a driver's use case. You can see the navigation instruction sitting on the road, telling you to keep going. There is another navigation instruction. And we know the car's position in the world with very high precision. So we can do lane-precise guiding. We can create truly immersive guiding. And everything is in 3D here. So, and as I said before, with putting driving relevant content into the driver's line of sight, we can reduce the cognitive load of the driver, and we can make sure that the driver keeps his eyes on the road. And so we hope that we can make driving safer. Okay, so we are not only dedicated to make driving safer for the people inside the car, but also for the people outside the car. So this helps to make the driver look on the road so he can keep his eyes on the road. And in the next example, we came up with a solution to avoid accidents with passengers. So in this example here on the intersection on the right-hand side, there is pedestrians crossing. And we can use augmented reality glasses to highlight this potentially dangerous situation and tell the BMW driver, maybe go a little slower here on this turn. And then, of course, we can just visualize any type of content. We can do traffic signs. We can show speed limit information. I sometimes tend to miss the speed limits, so we can make the driver aware. And we can also put we can put signs on the road. So here on the right-hand side of the roundabout exit, you can see this kind of traffic sign sitting on the road. And we usually put it there if there's defects on the road, like a pothole. We put it there, and so we can make the driver aware to go around this pothole. All right, so let's switch to the passenger. In-car entertainment is getting more and more important for us because people spend so much time in our cars. And with AR, we can create truly immersive experiences. So we tried to come up with a very little game, so please don't laugh, game developers out there, because this is a very simple game, but still very immersive game. So we call it Coin Collector. It's basically chips appearing along your route. They're locked to the world, and then you can collect those coins with the ring you see in front of you. And this truly just shows the potential of augmented reality glasses. So maybe you, game developers community, you can come up with some pretty ideas. And we can not only do gaming, we can also watch videos in the car. So we usually put it on top of the sun visor, so you can lean back and just enjoy your ride. All right, let's switch back to the driver. Parking is always an issue, and we wanted to come up with a solution which actually takes sensor data from the car systems. We have a system which is called parking distance control, and it shows you parking tiles with color and distance to the objects around you. It's usually shown in the center on our central information display. And we build an application which runs in augmented reality. So in this video, you're going to see two types of information. So here on the dash, you will see like the car with the tiles, but also outside the car, you will see the tiles. So truly immersive experience. And again, this shows the potential. We at BMW Research are mostly dedicated with doing the prototyping and showing what's possible with this technology. And what you can also see is that we are taking occlusion into account, so the tiles outside, so in the windshield, are occluded by the car, because we know the car's position and also how the car looks like. All right, this is it with the videos. Since this is a Unity conference, let's talk a little bit, just this slide, about how we use Unity at BMW Research. So Unity is great for bringing 3D scenes into our cars. We actually use it, as I said, for AR glasses, but also for head-up display development. Portability enables us to build on multiple platforms, because we don't want to do siloed solutions. If we do something for the AR glasses, it would also be great to put it like on other glasses and also on the head-up display. Now, we collaborate a lot with designers. So at BMW Research, we have designers and we have software developers. And designers come up with pretty mock-ups. And then they go to the software developers and are like, OK, please integrate this. And software developers are like, I don't know how to do that. So especially with OpenGL, this was really hard because you have to load your mesh and do the programming. So with Unity, you have this graphic user interface, and even designers can integrate stuff into our application. Unity Asset Store is great for quick prototypes. So sometimes we have to come up with a prototype within a week, and we can just go to the Asset Store. And so we collaborate a lot with universities. We have many students, and some students do, but most students do not have experience with Unity. So it's just a very low barrier for new developers to work on our projects. For example, with students, we mostly do driver studies. So just like a couple of weeks ago, we did a driver study on what is the best interaction modality in a car. So whether it's gesture, whether it's a phone, whether it's some button in the car. So our students come in, they build a little prototype, then we do a driver study and just do research on how we should do stuff in the future. OK, and this is my last slide, so thank you for staying with me. As I said, so this is a product we built at BMW Research. It's a concept. And there are many, many challenges on the road for in-car augmented reality. So the prototype we built is fully functional, so it actually works. But still, there are many things we need to get rid of. So I think one of the largest challenges, and this is nothing we can do as a car manufacturer, is to build glasses which are very lightweight. Even though I quite like those glasses because they're very lightweight. So this is about 70 grams compared to 600 grams for mixed reality headsets. But I would like these glasses to get even smaller. I would like to have them below 50 grams. So rather the form factor of a sunglass. So this is work in progress. Then ecosystem is a big topic. So what we are aiming for is kind of like with the smartphone. So if you have a smartphone and you buy your BMW, you just connect your smartphone once, whether it's Apple CarPlay or Android Auto. And we hope for the same thing for the AR glasses. So in the future, you have your pair of glasses. BMW is not going to sell you the glasses. You already use them in the future. And they are either connected to your smartphone, or you will just use them as a standalone device. And we hope for ecosystems which can seamlessly integrate those into our cars. And this is why we believe that there needs to be a collaboration with automotive manufacturers and glasses manufacturers, and also you guys, game developers, and also people who do software for glasses. Then, of course, there is all the legal aspects of AR glasses for the driver. I'm not going to comment on that because I'm not a legal guy. And since we're recording this here, I'm not giving any legal advice as an engineer. But yeah, this is something, maybe just put it in a nutshell. So I think this will be solved in the future, but we as a car manufacturer need to make sure that AR glasses do not distract the driver. So we can do driver studies. We can avoid the driver to look or watch videos when he's driving. And as I said, doing driver studies is very important. We do that already a lot at BMW Research because we would like to build the best possible UI for our customers.